Hi everyone. In this video I'm going to share how I compiled the Chromium example project for CEF on my Nvidia Jetson Nano model B01 running Ubuntu 18.04 bionic. CEF stands for Chromium Embedded Framework, and it's a framework that allows C++ applications to embed a browser within the application and use that as a user interface. It's a cross-platform project and framework, so it runs on desktops and it also runs on different architectures like the ARM CPUs, but I had to make a few modifications to compile it on the Nvidia Jetson Nano under Linux for the ARM 64-bit architecture. CEF itself is has pre-built binaries, so in this video I'm not going to go and through the build process for CEF proper. I'm just going to go download binaries for CEF for the Linux ARM 64 architecture. Those are available. I can just have them downloaded. Actually, the build process will download them. However, the CEF example project, I had to make a few modifications to that in order to build it on the Arch 64 architecture. So let me switch to Chrome. As you can see here in Chrome, I am in the CEF project repository under Bitbucket, bitbucket.org, Chromium Embedded, CEF project. This is the example project. And this is the wiki page for CEF itself, and it describes some of the binaries that I want to be able to build. These CEF client has a few a little bit more things to show than the CEF simple, but the goal of my video is to be able to compile and run these two applications on my Nvidia Jetson Nano model B01 under Ubuntu 18.04. And in this website, which is hosted by Spotify, this is the Chromium Embedded Framework CEF Automated Builds website. As you can see, there are multiple architectures: Linux 32-bit, Linux 64-bit. These are x86 architectures, Intel architectures. This is Linux for ARM, Linux for ARM 64. This is the Linux ARM 64 is the one that matches the Nvidia Jetson Nano's Arch 64 architecture. As you can see, there's also Mac OS, ARM 64, Mac OS 64-bit, Intel, Windows 32-bit, Windows 64-bit, and Windows ARM 64. So it's pretty widely supported. This particular version is currently the preferred one, the build for Linux ARM 64. But the CEF project will build whatever binary is it was I guess built with, so it may download a different version. So switching back to the Nvidia Jetson Nano, as you can see, the architecture is Arch 64. The architecture is Arch 64. It is running Ubuntu 18.04 bionic, and these are some of the prerequisites. CMake version, I have 3.16. Python version, I have 2.717, and these are the build dependencies that are specified on the wiki for the CEF project. But I also found that I need libgtk glex tmm -x11-1.2-dev. So the next step is to clone this page. This is the repo. Here, there's a CMake instruction for building CMake for Linux, running CMake on Linux. And I'm going to make a modification to this to specify the project architecture as it's done, for example, in this example here. These are for other platforms. This is for Mac, but it uses the project architecture keyword and it defines it. So, but as you can see, the Linux one doesn't, so it defaults to x86. And so what I've had to do is to just modify it so that I can provide an architecture. So I'm going to make this directory. I'm going to switch to that directory. And then I'm going to issue the git clone command. I'm going to issue the clone command, and it'll clone the repository here. And then I'm going to go into the CEF project directory. And as you can see here, there is a CMake lists file, the text file. And this is the file that needs a little bit of editing. And I'm going to edit it and show you the results. So in this line here, this is the CMake section for Linux. As you can see, it has it checks the pointer size to be, if it's 8 bytes, it'll declare it to be Linux 64, and if it's not 8 bytes for a pointer, it'll declare it to be Linux 32. However, Linux 64 stands for x86, Intel x86 architecture, so it'll end up picking the wrong platform on this ARM architecture. What I need to do, I'm going to just add some instructions here. If on the command line, I'm going to specify project arch, and I'm going to say if it's equal to Linux ARM 64. So if that command line variable, if that project arch is defined on the command line, then what I want to do is set CEF platform to be Linux ARM 64. And that's the end of it. So you do an endif, and that change should be enough for it to build. Now, when I do a git diff, I'll see this control M's showing up. I didn't put those in, but something that has something to do with the line endings between Windows and Linux. So, but it doesn't matter. I'm just going to leave those there and not worry about them because they don't affect anything. And if I do a git status, you can see that the only file that has changed is this one. So the next thing we have to do is to make a directory called build and go into that directory. And in this directory is where we issue the CMake command. So the CMake command is, as I type it in, you will see it says CMake -g Unix makefile. So that says, okay, build it for Linux, Unix. Now this is what I added, -d project arch equals Linux ARM 64. The rest of it comes from the wiki page, from the project instructions on how to build. -d CMake build type is release because I'm building release, and I'm telling it to go up one level, ... so that it can find the source code that it needs. I'm going to give that command and let it execute. What it's going to do is it's going to check the environment, and now here it's going to go download a binary, the pre-built binaries for CEF, And as you can see, it's downloading an older version, older than what's available today. This is 87.1.12. That's the last one that the example project was built with. And this will take a while. I'm going to pause and then come back. Okay, it looks like it's finished downloading. Now it's going to extract that binary. That'll take a little bit longer. So there's an expected delay here. Okay, so it took about 10 minutes for it to extract, and now it's running the rest of the build procedure. As you can see, it detected that it extracted the binaries that it downloaded from CEF's the automated builds, and it put it in this location, source bitbucket.org, Chromium Embedded CEF project. Under third party, there's a CEF subfolder, and under there, it's where this is the extracted contents of what it downloaded. There is another CMake variable that I could have set up to point it there, but that's okay. That doesn't affect anything. So it detected that it's building for Linux ARM64, building a release build, and it is building definitely for it's not building for Intel, so that's a good sign. So the build files are written in the build directory. So at this point, the only thing that needs to be done is to issue the make command, and the make will start building everything. If it had detected the wrong architecture, this first one would fail, and it'll give some errors about some things that are related to Intel architecture. So this process will take a while as well. I'm going to pause and come back. Okay, it's built the CEF client, so that succeeded, and it is linking CEF simple. These are the two binaries that I wanted to build, but it's at 66%, so it'll take a little bit longer to finish. Okay, so the build is finished, and looking back, there's a few instructions here that are recommended to set permissions for the sandbox for each one of these builds. So you may want to look at these. I'm not going to issue these commands because it seems like I don't need to, because I'm not running it in this video for the sandbox, but I just want to point them out. So to run, if I look in the build directory, what you can see is there is a third-party directory as well here. There is a third-party directory at the level above as well. So then, in order to run some of these programs that are built, I'm going to go to third-party/CEF/CEF binary with that long binary name, and then tests. And if I click, there's 4 subfolders. The one that I'm interested in is CEF client. I'm also interested in CEF simple, but in this video I'm not going to run it. It just puts up the application just puts up a web page in a browser, and it just shows the standard Google homepage. So I'm just going to skip it to CEF client directly. And since I want the release build, I'm going to go to the release directory, and then here I'm going to run the binary CEF client. And it is showing this, the application is running. I get these error messages for some reason on the Nvidia Jetson Nano, but whereas on Raspberry Pi I don't get that, and on Windows I didn't get it. But in any case, this is the web page that's launched by the application, and if you come to the top corner, you'll see on the there is a test menu that the application has put up. So there's a couple of options here. For example, I can zoom in. You can see that. So this is me as a user communicating with the application and telling it to do things. Zoom out, zoom reset. And print PDF, there's tracing, muting the audio. There's like get text, and then it shows the text, and I can go back to the previous page. And then there's other tests I can ask it to show. So there are a bunch of tests here. I'll run the accelerated 2D canvas here. See what that does. Yeah, okay. That looks like when I move the mouse, it's doing something to trace my mouse, and that's launched by the application. And then there's the WebGL demo, which again, I get a lot of these errors, but I don't get them on other platforms. And that's about it. This is what I was hoping to be able to do on my Jetson Nano, and get a successful build and be able to launch this. I hope this was useful, and catch you in the next video. Take care.